Geometry Honors, here we go with 11-7 day 1. The last video got over 100,000 views already. I think this one we can probably double that. So let's continue where we left off. We have to first go back to Chapter 8, was all about similar triangles. That'll be on the semester exam if we get to have one. It said if two triangles are similar, the ratio of their corresponding sides equals the ratio of the corresponding altitudes, medians, angle bisectors, and perimeters. Now, of all the words in that list, which one is most important to us right now dealing with area? Yeah, you got it right. It's the altitudes. So that's the most important one that we can do here. Now, this first problem is going to be a little bit slow, but then it will lead us to something to make the problems a lot quicker. So, but I don't want to just throw you in blind. So we'll see what happens on this one. So looking at that picture, you saw that a ton back in Chapter 8. You do know that triangle EGF is similar to triangle EKJ. So we know that right now. So maybe I'll write a note, just what the heck. You don't have to write that down, but it's going to be a part of our thought process though. So we have similar triangles. So what we can do is, again, I have not enough numbers to actually find the areas. So what I might do is I might say, well, I'm going to let this be the base of my small triangle. I'm going to zoom in if that's okay. And then I'm going to let this be the height of the small triangle. I'll let this be the base of the big triangle. And I don't like the picture to get too messy, so I'm going to do it outside. Hopefully you're not upset about that. And so there is the height of the big triangle. So let's see what we could do if I was going to actually try to find those areas. So let's see if I can use my colors the right way. So triangle EFG would be 1/2 times his base times his height. And if I was going to do triangle EJK, where's my red? There's the red. That'll be 1/2 times his base times his height. So everyone out there can say, yeah, okay, 1/2 divided by 1/2 is 1. That's fine, but there's still not enough information, Kaczynski. There's no way I'm going to get an answer to this. But if we combine what we know about similar triangles with the formula right in front of us, let's see what happens. We do know that the ratio of B1 to B2, those are corresponding sides, so that is a 4:7 ratio. The ratio of H1 to H2, those are corresponding altitudes, and so we know that is also 4:7. And so, believe it or not, it seemed like there was not going to be enough information, but suddenly we have the answer of 16:49. I think we should box that in, make it official. That's cool. Now, that was a lot of thinking. It would be really nice if there was a way to do these problems in a much quicker fashion. Let's take a look at the similar figures theorem. If two figures are similar, then the ratio of their areas equals the square of the ratio of corresponding segments. So here's the way the book wants to write that down. The ratio of area 1 to area 2 is the ratio of side 1 to side 2 squared. So it's the square of those ratios. Now, that's a very popular way to write it. This theorem will come back in Chapter 12. There's something to look forward to. Some people do actually like this version of the formula, little algebra property there. They prefer to see each number squared separately. So either one is amazing. Let's take a look. Now, again, this is a nice formula, but keep in mind it only works if the figures are similar. Now, we do it a lot with triangles, but it could be pentagons and hexagons and any other figures you've learned. All right, let's see how now we can use that to make this problem faster. So when I compare IML to ISE, once again, you don't have to write it down, but it has to occur to you that it is a similar triangles problem. If you don't realize you have similar triangles, then you're just going to be stuck and you're not going to be happy. But if you realize that, let's take a look. IML to ISE, we want the ratio of their sides. Oh, well, the ratio of corresponding sides is 5:8, but because they're similar, I have to square that, and so that's 25:64, and that was not too painful. Now, once we know that, we can actually go a step beyond and start comparing the triangle on top to this guy right here, which hopefully you realize is a trapezoid. And so now we have lots of things. We have the small triangle on top, the trapezoid in the bottom, and the entire triangle there. So now I can ask you lots of different questions. Everything though, no matter what I ask you, you have to do the first problem first. Even if I don't ask for it, you have to figure out the 25 to 64 before anything else can happen. So why is that important? Let's take a look. I might scroll up. I don't know. I just feel like it. So what you figured out right there is that this top triangle represents 25/64 of the entire figure. So now using some quick math, you can figure out that, well, everything down here is the leftovers. So do 64, take away 25, and you get 39. So the bottom trapezoid is 39/64 of the entire triangle of ISE. So now let's take a look. Now it wants the area of SMILE, which is our trapezoid, 39, to triangle ISE. Oh, guess what? That was the entire thing that we already had written down, 39/64. That's awesome. And now it wants IML. Well, the IML was 25/64, so that's 25. The SMLE was 39/64. So that doesn't, not the right color, but that's okay. And that's the wrong number. I said 39. All right, and so that was a way that we can do that. Hopefully that makes sense. If not, we'll just practice it 100 more times. Make sure to ask questions if you have them. Peace out.